To simplify several multiplied terms that have the same base but different exponents, keep the same base and add the exponents to get your final answer. Let's break it down. The first thing to check when multiplying exponents is that each of the terms has the same base. Remember, the base of an exponent is the bigger number to the left. Let's see an example. In this example, we have two terms here raised to exponents. The first term has a base of x, and the second term has a base of y. Since these bases are different, we cannot combine them into a single term. But let's do a different example. In this example, both terms have a base of x. We have x cubed times x squared. So, since they both have a base of x, we can combine them into a single term. So, how do we do this? You may remember that exponents mean repeated multiplication, where the exponent tells you how many times to multiply the base. X cubed is the same as x used 3 times in multiplication, and x squared is x used 2 times in multiplication, or x times x. If this isn't familiar, review the topic exponents and integers. So what if we rewrite our original expression here using these expanded versions, where I'm going to replace x cubed with x times x times x, and I'm going to replace x squared with x times x. So I've rewritten x cubed here as x times x times x, and I've rewritten x squared as x times x. And so now we see that we have x multiplied together not 3 times and not 2 times, but actually we have it multiplied a total of 3 plus 2 times. So we could rewrite this as x raised to the power of whatever 3 plus 2 is, which equals x to the 5th power.
So are you saying that I can just add the small numbers and keep the big number to get my final answer?
Right. You add the exponents, which are these small numbers, and keep the same base, which is the big X here, to get your final answer. So in this example, our exponents were 3 and 2, and so we added those to get 5, and our bases are x and x. They're both the same, and so we keep that same base of x to get x to the 5th. In this example, we have x to the 6th power times x to the 4th power, and so using the rule that we just talked about, this would equal x raised to the power of 6 plus 4, which equals x to the 10th power. Let's try one more example. In this example, we have y cubed times y. What do you think this would equal?
Since there's no exponent on that second y, should I do 3 plus 0 to get the final exponent?
This is a good question. Remember that when we have a term raised to an exponent, the exponent tells you how many times to multiply the base by itself. So y cubed would be y multiplied 3 times. Over here, we just have y multiplied 1 time. So that would be the same as if it's raised to the 1st power. Our exponent here is a 1 instead of a 0.
Cool. So our final answer is y raised to the 3 plus 1, which is the same as y raised to the 4th.
Exactly. Great job.
So what happens if there are more than 2 terms that have exponents and are multiplied together?
If we have more than 2 terms, the rule still applies as long as all the terms that we're multiplying have the same base. For example, we have w to the 4th power times w to the 5th power times w squared. So when we multiply these, we keep the same base w, and our exponent is the sum of all these. So all of these exponents added, which equals w to the 11th power.
So, to simplify several multiplied terms that have the same base but different exponents, keep the same base and add the exponents to get your final answer.
Exactly.